The Open Systems Interconnection Model, or OSI model, has 7 layers. Starting with layer 7, they are application layer, presentation layer, session layer, transport layer, network layer, data link layer, and the physical layer. Each of these layers have a specific role for computer networking. There are protocols to follow within each layer so that the technology is always working properly. Each layer talks to their corresponding layer, and they are all essential for successful networking. As we go up the model, we move from hardware closer to software. Layer 1, the physical layer, involves the method of moving data between computers. The physical hardware is needed to send and receive data. The hardware includes network connectors, cabling, hubs, fiber optics, radio waves, etc. Its main purpose is to move the data from system to system. The network starts with the network interface card, also called the NIC. This serves as the interface between the PC and the network. In the NIC, there is firmware called the Media Access Control Address, or MAC address. This is a unique identifier similar to a student ID number. No two MAC addresses can be the same. The NIC can also be put in the data link layer. All networks transmit data by breaking whatever is moving across the physical layer into discrete chunks of sending software called frames. A frame is a container for these chunks of data moving across a network. The NIC creates and sends, as well as receives and reads these frames. The NIC builds a frame of data to transport it to the receiving NIC. Then it goes through the frame check sequence, or FCS. After that, the NIC puts both the destination MAC address and its own MAC address into the frame. It then waits for a cable to be clear, just like trains on a train track, and then it sends it through the cable into the network. The frame heads to the hub where all devices on the network see the frame, but only the device that is addressed to it will process it. The Logical Link Control, or LLC, is responsible for dealing with incoming frames. Any device that deals with a MAC address is part of the data link layer.
The third layer is the network layer. This layer deals with switching and routing technologies as well as creating logical paths for transferring from node to node. Packets get created and addressed so that they can go from one network to another. They get addressed with an IP address and use some type of naming convention. No two protocols are the same. IP addresses must be configured by the network administrator. Routing and forwarding are the major functions of this layer. Routers use the IP address to forward data. It allows networks to connect across data lines that do not use the Ethernet. The fourth layer is the transport layer. It offers end-to-end communication between end devices through a network. It ensures that there is a complete data transfer. It assembles the packets from the network layer 3 for routing. Some of the functions offered by the transport layer are application identification, client-side entry identification, confirmation that the entire message has arrived, and segmentation of data for network transport. A real-world example of this is receiving a package from UPS. To make sure a customer gets all of their packages in one shipment, UPS puts a number system on the label of each box. Embedded into the data of each packet is a sequencing number. By reading those sequencing numbers, the receiving system knows the total number of packets to put them all together. The fifth layer is the session layer. It establishes, manages, and terminates connections between applications. It handles all of the sessions for a system and initiates sessions, accepts incoming sessions, and opens and closes existing sessions.
Hi, class.
The sixth layer is the presentation layer. It establishes context between the application entities layer. Higher level entities may use different syntax and semantics. It provides independence from data representation by translating between application and network format.
Okay, so for a real life example of this, I decided to choose an iPod because on an iPod you could either listen to a song, which is an MP3 file, or you could watch the video, which is an MP4 file. So say you just want to listen to a song. The iPod knows not to play the video. It would only play the MP3 file instead of the MP4 file. But if you want to watch a video, it knows just to play the MP4 file, not the MP3 file. An analogy for this would be a toll booth. So you have Easy Pass or you have cash. So there's usually like 2 cache lanes, and the rest are all EasyPass. And the user knows when going into the cache lane that they can't use the EasyPass, and vice versa, when they want to go into the EasyPass lane, they can't use cache. So the toll booth differentiates between the 2 entities and makes traffic go smooth.
The 7th layer is the application layer. The application layer is pretty much the user interface. The OSI application layer is responsible for displaying data and images to the user in a human recognizable format and to interface with the presentation below it.
Okay, so for this, a real life example I like to use would be instant messaging. On instant messaging, you could either use AIM, Yahoo, MSN. Now you could even use Facebook. All the user sees is the interface, which is an IM that pops up with whatever someone sent you. So they don't, the user doesn't see anything that goes behind it, what's going on at the other end on the other user's computer, or what it takes for the message to get from one computer to the other over the network. An analogy I like to use for this one would be a birthday cake. So when a kid's real little, he's very excited it's his birthday. All he sees is a very nice birthday cake his mom prepared for him. He doesn't know, like, when he's during the day, he just doesn't know, like, his mom's going out to the supermarket, she's baking, she's doing all this stuff. And all he wants to do is just for everyone to sing happy birthday so he can blow out the candles and lick the icing off.
Each layer in the OSI model defines an important function in computer networking. The 7 layers are the application layer, presentation layer, session layer, transport layer, network layer, data link layer, and physical layer. All of these layers are used in many different applications in the real world.